All right, let's see. All right, take a look at that first one there, if you would. You get 1, 2, and 3. Make sure on the side it says 6, 5. Okay, we're going to start with that. We'll kind of go through there. I do need to see some work for that. No. We're going to do a couple together, and then you're going to do some of it. So stick with me here. Make your phones, earbuds, all that crap away, please, on here. I did that. Did I not do that? Nope. Austin, what'd you put for the first one? I saw you had an answer down.
I said yes.
You said yes, it's a solution, and I believe you're right. Now, what you got to do, show me just a little bit of work. Plug it in. So 6 goes in for y, and then 1 goes in for x. And so you just simplify, and you get 6 is less than 7, which is true. So it is yes. All right, so have that down for number 1. So that is yes. Let's hop to number 3. Hop to number 3 and plug those in. For y, you're going to plug in -3 is less than or equal to minus x, which is -5 plus 2. And it looks like I get -3 is less than or equal to -3. Audie, yes or no now? What will be our final answer once we get down to that point? Yeah, that'll be correct. So yeah, -3 is equal to it. So you would say it is a solution for that. All right, make sure you stay with me and do the ones we do because you may not have to do all of them. Let's go to number 6. Okay. So for number 6, x plus y minus 1 is less than 0. What do we got to do first, Kyle?
Me?
You.
Get y by itself.
So I got to move 2 things. So you got a little bit of room here on the right. So I got x plus y minus 1 is less than 0. So, all right, how do you propose that, Kyla?
Can you just subtract the y or add the 1 and then subtract x?
I would probably move the other 2 because the only reason I wouldn't is you don't want to make it, when the y is negative, it just makes things more complicated. So you can go ahead and move both of these at the same time. Subtract x and add 1. That's going to give you y is less than -x plus 1. Okay, y is less than negative. So we're good. We got y by itself. Rate, slope, y-intercept.
Slope would be -1 over 1.
Okay, and y-intercept.
Y-intercept would be 0.
So now we can graph it. So put a dot at 0, 1. Don't forget, negative slope. Downhill. Okay, and so I'm going to go down and then to the right, down and to the right. John, do you remember solid or dash line?
It's a dash.
Dash. What makes a dash?
If it's just less than or greater.
Good. There's no equal to part, so that would be correct. All right. I still think on the next part we're a little bit of hit and miss on here. Linda, do you remember what we shade or how to do that?
Is it
It is below. Less than is below. Now, if we forget, Allie, I gave you a way you can figure it out. Do you remember what the way is to figure this out if you forget whether it's above or below?
Zero.
Test point. Test point. Yep. You plug in a test point, and I can plug it into the original or I can plug it into the Y. It doesn't matter. And like you said, 0, 0 is usually what we use. If I plug that in, since it's shaded, it should make it true. 0 plus 0 minus 1 gives me -1. -1 is less than 0. So we shade the side that is true. Okay, so we shade that. All right. Read through number 7, please. Read through that first part there at the top. And see if we can create an inequality for this case. The most you can spend is $20. You get chips and pretzels. $4 for chips, $2 for pretzels. Any idea of how we can combine that information in inequality? Kyle?
4C plus 2P equals 20.
Okay. One thing that is going to have an inequality. Everything's good. 4C plus 2P. It doesn't have to equal 20. It could be. Can it be greater than 20 though?
Oh, less than or equal to.
Less than or equal to 20.
You scream.
All right. Write that down if you have it. So it's less than or equal to 20. All right. We want to graph this. So let's all be on the same page. And you're used to X and Y though. We have a C and a P. Where do we want the C? And it doesn't matter. Do you want the C on the X-axis or do you want it on the chips on the X-axis or do you want it on the Y-axis? It really doesn't matter. We just make it all the same. So just for ease, put chips on here. And then we got pretzels there. This is one where we can get away without getting a letter by itself. Anybody figure out how we can graph this without solving for a letter? We've done it before. What's that? Not necessarily have 4 over 2 at this point. Hey, think about the X and Y intercepts. Do me a favor here. If you cover up the 2P, what C value will make that true? What does C equal? If I let P equal 0, C has to equal what? 5. So that would be the point 5, 0. If you cover up the C, what would make the other 2P equal to 20? 10. Those would be our intercepts. We can graph it using those two. Just make life a little bit easier. So now you watch here. Can we fit our scale? There is no scale written. Can we make it 1? Will that work? If I go 1, just label everything 1, 2, 3, 4. Will that give me enough to hit those 2 points? Will on the bottom and will on the side. So I'm going to do that. I'm not going to label every one. I'm going to label every other one. So I'm going to go 2, 4, 6, 8, 10. And then here I'm going to go 2, 4, 6, 8, 10. So 5, 0 will be here. 0, 10 will be here. Go ahead. Connect that with a solid line. This one here, I would do a test point because we didn't get Y by itself. Let 0, 0 be your test point. Kyle, are you getting this down? All right. Let 0, 0 be your test point. And then see whether it's true or false. So, and this is an easy one. If these are both 0, what am I left with on that left-hand side? I'm left with 0. Is that less than or equal to 20? Yes. So that means we're going to shade the side that contains 0, 0, and we're going to shade below that line. There's your graph. It says give 2 possible combinations of bags of chips and pretzels that Clark can. So this is basically what are two solutions that work. So here's your chips. You can't go past 5. Here's your pretzels. You can't go more than 10. But what are some combinations we can get? John, does that make any sense?
Yeah, it'd be 4-1.
4-1. So if you did 4-1, which would be right here. So it'll be 4 chips. Let me change right there. Okay, 4 chips. And 1 bag of pretzels. All right, so he's good there with 4-1. Riley, what would be another one? Another combination.
2 and 2.
2 and 2. So 2 chips and 2 pretzels. Okay, I agree. 2 chips and 2 pretzels. All right, now we did this before. 8, 9, and 10. Let's just do number 9. You got to come up with the equation, the inequality. So if you look at number 9, it's a dotted line and it's shaded below. So we're going to start it with y, and then what inequality am I going to have? Greater than, less than, greater than or equal to, or less than or equal to? There's no such sign as greater than, less than.
Less than or equal to.
Okay.
No, just less than.
Just less than. All right. It is less than. So you want to come up with the y-intercept and the slope. There's my y-intercept. Find another nice point where it hits. Figure out the slope. Okay. Figure out the slope. Tyler, you got it?
Me? Oh.
Tyler.
Is it +3?
It is +3 because if I go up 1, 2, 3, and over 1, I got another point. So now I'm going to make this. So do you, Kyler, do you know the final, what I would put down there for the whole thing?
3 over 1.
Okay, you just make that 3x is fine. And then what?
+1.
Plus 1, you got it. Y is less than 3x plus 1. All right, flip that over. Flip that over. This is more like we did yesterday. And let me see what we got here. All right, let's take a look at number 1. How can you tell whether it's a solution of the system? It has to be true for what? Both of them. All right, do a quick test it. Test it for both of them. See if they both work. We're going to do this here. We're going to do this one and we're going to do one more.
Wait, is it number 1?
Yeah, number 1. I know it doesn't give you a lot of room.
No solution.
Christiana, does it work for the first one?
Yeah.
Okay, so I plug in -2, and then I got 2 minus 3, so I get -2 is less than -1. That is true. So it works for the first one. All right, Austin, does it work for the second one?
No.
He says no. So let's take a look. If I plug in -2, is it greater than? All right, I'm plugging in 2 there. So this is -2 is greater than -1. Is that true? No. So this is not a solution.
-2.
Okay, so not a solution. All right, let's go ahead and hop to number 5. We're going to do that one together. All right, first one, we can go ahead and graph. Less than or equal to 1/2 x plus 1. All right, wait to shade everything because we got two of them. 1/2 x plus 1, start at 1. Go up 1 over 2, down 1 over 2. Solid line. All right, Allie. In the end, are we going to shade above or below that line? What tells you above? You're just guessing?
Yeah.
All right, that's it. How do you read that symbol right there?
Less than.
So less than. Think less than, and you got to compare that to above and below. So if something's less than, is it below or above? It's below. So this is going to be below. And so you're going to draw that arrow underneath there. So don't shade yet. Johnny, what do we got to do on that other one here before we can graph it?
Subtract the x by both sides.
Subtract the x, you get y is less than negative x plus 3. This is again going to be below when we're done. It's going to be below. All right, graph negative x plus 3. So go to positive 3. Down 1 over 1. Make it solid. Braden, above or below?
Below.
Okay, now we got both of them are below. Where are they going to overlap? Okay. It has to be below. In my case, the black and the blue line. That'll be right here. What's that?
It's supposed to be a dash line.
Ooh, yes. Thank you. Make that a dashed line. I'll cheat a little bit here. Thank you. All right, so yes, that should be dashed. Directions say give 2 ordered pairs that are solutions, and then 2 that are not. So under A, 2 that work. Under B, 2 that don't work. Okay, for that. Erica, what would be 2 that work?
1 and negative 2, and 3 and negative 4.
Okay. And Austin, how about 2 that don't work?
1 and 5.
Okay.
You want me to know?
Yeah, give me another one. 2 and 4. Okay, agree. All right, you're going to turn this in today. I want to turn it in. We're going to grade some of it, so make sure that if you're unsure, you get help before you turn it in. You do not have to do number 7. Okay. If you want to try it, we'll count it as a bonus with minimal help. Okay. Do everything else first, though. Start on you gotta do it. Now you're going to finish the rest of the front, and then finish that. Turn this in today.
And the charger.
Whoa!
I'll finish your quiz out.
She's supposed to do 5, wasn't
Huh?
she? She's supposed to do 5. That wasn't much, but,
Wait, let's do